So we're going to start with material balances. And let's state that the conservation of matter states that matter is not created nor destroyed, but it may be transformed. So it can suffer transformations. So in other words, materials that are entering a system could be a process or could be a unit operation, must go out of the system or it is accumulating in the system. This will help us to make a material balance. Now, a material balance is just an inventory of what is happening to a substance. The substance can enter, it can go out, it can be produced, it might be consumed, and at the last, it could be accumulated. This material balance can be for any given substance, but we can also say it happens in life. We have the population of a city, and in the city, people can enter the city. They are immigrants, or they can go out of the city. They are going to leave the city. They can also be born, or they can also die. At the very end, that will give us the accumulation of people that we will have in a city. This can happen for materials, and this is valid for either the whole substance or the whole mixture or the whole process, but it also can be for one unit operation. And we can also be doing this for certain components. I can do the material balance of component A, component B, component C in the process. Now, whenever we say that the process is in steady state, the accumulation is going to be zero. We're not going to have any given accumulation. What enters can go out, what is produced is going to be consumed. And the production and consumption are going to be zero if we don't have a chemical process. Later on, we're going to be studying chemical process. So if it is steady state and there is no chemical reaction, we can actually say that what enters the process is going to be equal to what has to go out of the process. A differential balance is a balance that is going to be analyzed in what is happening on an instant of time. And this type of balances usually applies to a continuous process, and we have rates, which is a picture of what is happening at a very instant of time for a process. Now, it could have a steady state where the accumulation is zero, but it could be on steady state, right? Where what it is entering is accumulating in the unit operation. While the integral balance is a balance that is describing what is happening between two instants of time. Now, the two instants is the starting instant, then the final instant. And this is usually in a batch process. In a batch process, you are going to input things, that's the first instant. Things are going to start happening, right? And after the reaction or whatever is occurring passes, it ends the process, then the second instant that you are going to be analyzing is the end of the process. And we're going to be analyzing amounts here. You're going to input an amount, and you're going to output certain amount. Now, in order to solve a problem that deals with material balances, the first step is to read the problem, and afterwards you have to perform the diagram of the process with the known variables, and you have to state which are the unknown variables, which are the variables that are not given in the problem. Now, if you need a basis of calculation, then choose it. Sometimes it is already given. You are given with a flow that is already the input, and that would be the basis. Otherwise, if you do not know it, you do not know any flow, then you can choose a basis of calculation. So this is a flow rate or an input of one of the streams in order for us to start performing calculations. Then turn everything into mole or mass basis. If something is given in moles, but you need mass, then turn everything into mass. If you are given flow rates, volumetric flow rates, turn everything into the same basis. Sometimes you can choose between mole or mass depending on what is more convenient, but sometimes you are going to be, the problem is going to state, what do you want or what do we want? After you have already stated all the diagram of the process, the next step is to write the material balances that are going to pop out of the problem. You start with an overall, what is entering overall to the system, what is going out, and then you can go component by component. If you have more unknowns than equations, then it means that you cannot solve this with the material balances, and most likely you will have to do other kind of balance later on, like let's say energy balance. But right now you're going to be only concentrated in material balances, so you will have the same amount of variables, unknowns, than of equations. Probably you will even have more equations than unknowns. After that, you have to solve these equations, and then if these are the answers that you are looking for, you are done. Otherwise, you can calculate the quantities that are requested in the problem if they have not been calculated. Let's say that you find some amount of moles, but you are being asked to determine volumetric flow. So you will turn this amount of moles into volumetric flow, right? So usually these are the 3 steps that you need to do in order to solve a problem.